Assalamu alaikum everyone. My name is Zain Sohail and I am from BS Biotechnology batch 17. This presentation is being submitted to Dr. Hammad Majeed and the topic of my presentation is Borax. This is the table of content. I'll firstly give you a short introduction about Borax, then to the history of Borax, then chemistry of Borax, the natural resources, toxicity of Borax, uses of Borax, and resource data from which I have collected this all information. This is actually how borax looks like. Now let me give you a short introduction about it. Borax is a powdery white substance also known as sodium borate, sodium tetraborate or disodium tetraborate. It's widely used as a household cleaner and a booster for laundry detergent. It's a combination of boron, sodium and oxygen. Borax is often found in dry lake beds in places like California's Death Valley, where the water evaporated and left behind deposits of minerals. Boric acid is made from the same chemical compound as borax and even looks like it. But while borax is commonly used in cleaning, boric acid is mainly used as a pesticide. Boric acid kills insects by targeting their stomachs and nervous systems. Both borax and boric acid in loose powder form can be harmful if swallowed, particularly for children. They can also irritate your skin. This is the formula of borax as given below. Now let me tell you about the history of borax. Borax, which is also known as sodium tetraborate, became important in European Middle Ages as a flux for soldering, that is, for cleaning the surfaces of metal pieces to be joined by being melted together. Native European sources were unknown, and the nature and origin of this mysterious metal was long a puzzle to chemists. Borax was ultimately traced to Tibet, almost the only known source until the discovery of 1776 and exploitation of 1820. Italian springs of boric acid, hydrogen tetraborate, which could be converted by the addition of soda into borax. Italy became the principal source of borax until the 1860s, when deserts areas now in Chile began to supply borax. The key figure in the discovery of borax North America was John A. Viach, who found it in California in 1856, first in springs at the north end of the Sacramento Valley, and then in large quantities in a cut-off bay of Clear Lake. Viach himself stated that the discovery was accidental, sparked by the presence in the region of an Englishman who had formerly worked for a London borax company. The California Borax Company was organized to exploit this source, and the company struggled for a decade to extract and purify material encrusted on the bottom of an isolated wilderness lake. In 1857, Viach's explorations took him to Southern California, where he found borax in the waters of mud volcanoes and Colorado Desert. Within the next decade, borax was found in surface incrustations in more convenient locations in Nevada and Southern California. In 1871, the Mining and Scientific Press of San Francisco reported borax to be all the rage, with production in progress at Columbus, Fish and Teal Marshes, Esmeralda County, Nevada. In 1880, the production began in Death Valley, California, where this famous 20 mule team wagons carried it out at the below the sea level depression to the railroad junction at the Mojave, 160 miles away. These surface deposits of borax were largely sodium calcium tetraborate, known from their appearances as cotton balls. Their conversions to true borax was chemically simple but difficult in practice. American producers mastered the conversion process by the mid 1880s and supplied the domestic and international markets. However, they drove the price down to a level that caused most producers to fail. The principal survivor, Francis Borax Smith, employed Stephen Mather to promote borax in 1896, starting with a pamphlet advertising 200 recipes for borax. This successful advertising campaign greatly expanded the demand for borax, which had relatively become inexpensive, especially in washing powders, glass, and ceramic glazes. Although Smith controlled nearly all American sources of borax, financial troubles with his other investments forced him to merge with the English borax company Redwood and Sons in 1896 to form a company known in the early 2000s as US Borax. Exploitation of shallow deposits terminated once drilling began in the Mojave deserts at a site marked by the company town Boron. In the 1970s, the production there and at Searles Lake, California, exceeded 1 million tons per year and satisfied the borax demands of the United States, Europe, Japan, and many other parts of the world. Now let's move to the chemistry of borax. From the chemical perspective, borax contains the P4O5 OH4 2 ion. In this structure, there are two 4 coordinate boron centers and two 3 coordinate boron centers. It is a proton conductor at temperatures above 21 degrees Celsius. Conductivity is maximum along the B axis. Borax is also easily converted to boric acid and other borates, which have many applications. Its reaction with hydrochloric acid to form boric acid is given below. Borax is sufficiently stable to find use as a primary standard for acid-based trimetry. Molten borax dissolves many metal oxides to form glasses. This property is important for its uses in metallurgy and the borax bread test of qualitative chemical analysis. Now let's move to natural resources of borax. Borax occurs naturally in evaporate deposits produced by the repeated evaporation of seasonal lakes. The most commercial important deposits are found in Turkey, Boron, California, and Searles Lake, California. Also, borax has been found at many other locations in the southwestern United States, the Atacama Desert in Chile, newly discovered deposits in Bolivia, and in Tibet and in Romania. Borax can also be produced synthetically from other boron compounds. Naturally occurring borax, known by the trade name Razorite 46 in the United States and many other countries, is refined by process of free crystallization. Now let's move to toxicity of borax. Boron, often in the form of boric acid, is widely used as a flame retardant in insulation products, and although humans ingest boron through food, high exposure may lead to unwanted health effects. We assess the toxicity of boric acid, borax, and other forms of boron after inhalation, dermal, and oral exposure. After oral exposure, boron is absorbed over the gastrointestinal tract, and intact skin seems to pose a more effective barrier to boron than compromised skin. Boron excretion seems to mainly occur via the urine, although after the skin exposure, boron has been demonstrated in bile and gastrointestinal contents. Inhalation toxicity data are sparse, but one animal study showed reduced fetal weight after inhalation of cellulose that had a boric acid content of 20%. Skin exposure to boric acid has proven fatal in some cases, and the range of toxicity effects include abdominal as well as local effects on the skin. Fatalities from boric acid also have occurred from oral ingestion, and the endpoints in animals are weight loss and reproductive toxicity. Concerning genotoxicity studies, the overall picture indicates that boron containing compounds are not genotoxic. Now, let me tell you the uses of borax. Borax is known to serve as a precursor to several commercially important compounds of boron, the most notable of which is boric acid, which is widely used as an insecticide. It is not common for borax to be used in photographic developers as an alkali. Borax is also used as a flux in certain metallurgical processes. This compound is known to serve as cross-linking agent during the preparation of slime. The field of biochemistry is known to make extensive uses of borax for the production of buffer solutions. In several cooking techniques, the compound is known to serve as a texturing agent. Borax is also used in the neutron capturing shields for the safe storage, transportation, and the use of radioactive substances. This compound is also known to act as antifungal agent and can therefore be employed to kill fungi or inhibit their growth. It can be noted that borax has the ability to serve as a flame retardant. Several cosmetic products, enamel glazes, and detergents are known to contain borax. These are the links that I have collected my data from. You can check it out as well and make your assurance. Thank you for listening.